All right, so now let's put it all together. So basically, we just saw that if we take a parent function and we add or subtract to it inside or outside, that's going to shift it left, right, up or down, respectively. If we change the signs, that's going to flip it on the outside. If we change the signs, it's going to flip it upside down. If we change the signs on the inside, it's going to flip it left to right. And then the last thing we talked about is if we multiply, that's going to either stretch it or it's going to compress it, right? Outside, it's going to be a vertical stretch or compression. Bigger than 1 means stretch. Between 0 and 1 means compression. On the inside, if we multiply by a number bigger than 1, then it's going to be a horizontal compression. And if we multiply by a number between 0 and 1, it's going to be a horizontal stretch, right? And so basically this page right here gives you kind of all those different levers. So H and K are the adding and subtracting levers. So H is inside, K is outside. If you remember when we talked about the equation of a circle, H and K were the center, right? And so a lot of times you'll see those in that position where the number that you're adding to or subtracting from X is called H, and the number that you're adding outside or to Y is called K. All right. And so, so those have the kind of the same characteristics here. So H and K are your shift levers. So they shift left and right in the case of H and up and down in the case of K, right? And you can see right here, down here at the bottom, you can see that it tells you which way it goes, right? If H is negative, then that means it's going to shift right H units. If H is positive, it's going to shift left H units. And then in terms of vertical, if K is positive, it's going to shift up. And if K is negative, it's going to shift the graph down, okay? And so then you have your sizing changes, right? Or let's go to reflection first at the bottom here. So reflection, you can see if B is negative, so B is the number that is inside multiplied by X, okay? So it's the number that we multiply on the inside. If B is negative, that's going to be a reflection across the Y-axis, right? A is the number that we multiply on the outside of everything. Okay, so A is the outside multiplier, and if A is negative, then that's going to be a reflection across the X-axis, right? Which means top to bottom or a vertical reflection. Okay, all right, and then A, if A is greater than 1, if the absolute value of A is greater than 1, it's going to be a stretch by a factor of A. If the absolute value of A is between 0 and 1, it's going to be a vertical compression by a factor of A, right? Okay, so all this stuff on this in this right-hand column is vertical. Okay, it's all the stuff that's happening outside, right, away from the X that's happening outside. And then B is whatever you're multiplying inside. If B is between 0 and 1, absolute value-wise, it's going to be a horizontal stretch by a factor of 1 over B. And if B is greater than 1 absolute value-wise, it's going to be a compression by a factor of 1 over B. Okay, so that's horizontal, and that's all that stuff happens inside, right? So if you notice the stuff that happens inside, B and H, that's all horizontal, like you see in this column here. Okay, everything that happens outside is A and K, and that's all vertical, right? So you can see those are all vertical changes. And remember, whatever happens inside with horizontal is backwards of what you might think. So negative goes right, positive goes left, bigger than 1 goes actually shrinks, between 0 and 1 actually stretches. And so, yeah, so you gotta remember those are always kind of reverse of what you think. Whereas on the outside, everything's kind of as you might think, as you might imagine. So positive, if you add K, that's going to move up. If you subtract K, it's going to move down. If A is greater than 1, it's going to stretch it vertically. If A is between 0 and 1, it's going to compress it vertically. Okay, so those are all your levers, and you can see for all these different functions, right? And we're not going to use all of these functions, but again, this is a list you can take with you and use in the future, and it works with all these different types of functions, these different types of parent functions. But the main ones that we're going to stick with are basically these first 6 or so, and then probably greatest integer as well, and maybe floor. Okay, maybe we'll get into exponential a little bit too, but basically you can see these top ones, pretty much look the same. The key part is knowing what's inside and what's outside, right? So inside, when you're dealing with exponents, that's pretty clear because you're going to have, it's going to be inside the parentheses if it's inside. Radicals are pretty straightforward too, because it's going to be underneath the radical is going to be inside. And if it's not underneath, it's going to be outside. Absolute value, similar thing. Inside is inside the absolute value. Reciprocal is a little tricky because the denominator is the inside, because that's where x is with the reciprocal function. Exponential, the exponent is what's inside. And so anyway, so those are the different types of functions, and we'll get a lot of practice with those to see kind of what it's doing. But basically what we want to do is we want to be able to look at a function and be able to recognize what's happening with this. Are we moving it? Are we shifting it left, right, up, or down? Are we stretching it? Are we compressing it? Is it vertical? Is it horizontal? Are we reflecting it? So all those different things we'll be able to tell just by looking at a function now.